Hi, welcome to the Calculus 2 lecture series. And we are going to start unit number 2 for this video. And unit number 2, we're going to talk about the techniques of integration. So for the previous unit, the first unit, unit number 1, and we kind of generally discussed different type of the applications of the integration. So for this unit, we're going to focus on different techniques we can use for taking the integration. So, right before we finish the calculus 1, we talk about one technique that is, we call this the substitution rule, right? So some people say it's U sub. And for this lecture, the first lecture, we're going to talk about another very, very useful and the good techniques, we call it integration by parts. Integration by part, this technique probably, beside the U sub, integration by parts probably will be the another most frequently used technique. Try to do the integrations here. Okay, so let's go ahead, start, and let's go back to our lecture notes and to see what we're going to talk about, the integration by part, and what is the formula we can use. So the key concept in this lectures here, so basically we want to evaluate the integration, okay, by using the integrate by parts here. Methods here. So for the first video, I'm going to talk about just in general, what is integrated by parts and what is the formula? How do we apply the formula to carry out the integration? And some of the problem, if you use integrated by parts, will become tedious because maybe you need to use once, twice, or 3 times for the integration by parts. So for the second video, I'm going to kind of show you a shortcut or a kind of trick. We call it how do I use the table methods here, try to be easily to do the integration by parts type of the problems here. Okay, so what is the integration by parts here? So first, let me write out the formula for the integration by parts. So the integration by part, we say is if you integrate u dv, then this one here will be equal to the uv minus v du. Okay, so this is our formula here. But what is the meaning of this formula and what's that try to tell us here, right? So this is our integrating by part formula. So let's take a look. What is this formula come from and what we can do about it? So, in the calculus 1, let's kind of do a brief review. In the calculus 1, we have, if you have like f of x times gx, right? So if I want to take the derivative of this function, f of x times gx, so I think everybody from now, we should know what type of rules I'm going to use. I'm going to use the product rules, right? So the product rule will tell you, well, I take the derivative of this ones here, it will be you hold one function constant, then take the derivative of the other one, plus you hold another function constant, you take the derivative of the first one. Okay, so by the integration, by the product rule, I know if I want to take the derivative of f of x, gx here, right? So by the product rule, what will tell you? So will tell you it will be what is here. So we say, okay, so that means you take the derivative of the first one. So it's f prime x, right? And the gx. Then plus you hold the first one. So it's f of x, g prime x, right? That's what is the, we call it integration by parts. Now let's put it back. So if I want to put it back, I said, okay, now I take the integration both sides. Okay, so if you take the integration both sides, that means in here, okay, so now that means I'm going to take the integration here, integration here, integration here, right? So if I'm taking the integration both sides, then let's take a look at what happened. If you take the integration and you take the derivative, so what is the first term would be? Would just be the f of x gx here, correct? All right, so then this is when you take the integration, of course, I should say that in here you need to do the dx. So the same way is here is dx, and the same way is here is dx here, right? Okay, so now you will see here, so this will be the f prime x gx dx and the plus integration f of x g prime the x dx, correct? Okay, so now if I want to find the fx g prime x, so if I'm going to find this one's here, so what is this integration? So let me color code that, right? So this integration will just be the integration of f of x g prime x dx. Then you move this term to the left-hand side, it will be f of x gx minus f prime x gx dx, right? Okay, so over in here, I can write this one, maybe I can write better. So I can kind of put the, so this will be the f of x, I'm sorry, g of x, right? So this is g of x, then this is f prime x dx here, okay? So in here, that's basically if inside, okay, so here, take a look here. If inside your integration, you can totally separate to two parts. So if this is, we call this the f of x. So if let's say that u is equal to the f of x, then v is equal to the gx here. So if inside your integration, so if this is used, right, then the g prime x dx, g prime x dx, what is that? G prime x dx, what is this one here? This is what? This is dv's, right? So the dv will be equal to g prime x dx. So integration by parts said, hey, if inside you can separate it in two things, u and the dv, then it will become to the f of x gx, right? So this gx is v, right? So it's u times v. So just like we say uv. Then what minus here? Minus here, this is v. Then what is the f prime x? F prime x is what? Is du here. So the reason why we want to do that, the whole purpose is here is if I can separate which one is u, which one is dv. And then the goal is to make this part, all right? So the goal is to make this part is easier to integrate. So when you try to do the problem, so when you say which one I need to assign to be u, which one I need to assign to be dv, then the key kind of concept is you want to choose your u is easier to take the derivative. Then the way you assign to be the dv is easier to take the integration, right? Because then you are going to have the, uv, so you need to integrate one side, and then here you have a du, you want to take the derivative of the other side. All right, okay, so now let's take a look at the first one. See here. Okay, so now this is the x squared natural log x. Well, so which one I need to assign to be u, which one I need to assign to be v? See here. Let's take a look. We all know natural log x is pretty easy to take the derivatives, right? So I can sign this one is u is equal to the natural log x. Remember, we want one thing is easier to take the derivative, and one thing is easier to take the integration. So now what happened to my remaining? I have a remaining, this is x squared dx, right? So everything inside the integrations, you need to be replaced. So I have here, I say x squared dx, I let this is equal to dv's, right? So remember, right? So it's u dv's, right? So that's what is our formula, is u dv. So that's why this whole thing is really is change the integration u dv's here. U is natural log x, dv is x squared dx here. Okay, so now remember we said, okay, now one thing we need to take the derivative. So this part I'm taking the derivative. So when you take the derivative, u become to the du's, right? So what is the du? Natural log x is 1 over x dx, correct? All right. Now the next thing here, this one I need to do what? This one I need to do the integration. Because I want to, why I want to do the integrations here? Because I want to find the v's here, and here I have a dv. Okay, so x squared, how do I do the integration? Oh, easy, is 3x cubed, right? So it's x cubed over 3, then dv, you take the integration, is equal to what? It's a v's, right? So remember our formula will be the UV, so let's do a kind of a cross. So this is UV minus VDUs, right? So minus VDU, right? So UV and minus VDUs here. All right. Okay, so let's see here. So UV, so this integration, the whole thing here, UV, U times V, so it's what? It's 3x cubed natural log x, correct? Then minus, this is brown, minus here, right? V du, so it's a minus, you need to integrate. V du is 3x cubed times 1 over x dx here. All right, so now this is 3, this is x cubed over 3, the natural log x, and the minus, so simplify this is a little bit. So what is here is x to the square to the 3 dx, right? Okay, now see here, like remember we say the goal is to make this v du, right? So the goal is to make this VDU, when you do the VDUs here, the goal is to make this integration easier, right? So now in here, this is x cubed over 3, the natural log x. So x squared, everybody know how to take the integration. So it will be 1 over 3rd. Then this is x cubed to the 9 plus the 6 here, right? Okay, so now what is my final answer? My final answers here will be x cubed to 3, the natural log x. And oh, I'm sorry, this is minus 3, so not 9. 2 plus 1 is 3, right? So it's a minus x cubed to the 9 plus c, right? So this one, it will be, okay, so this will be our answer. Okay, let's take a look at the second one, is x cosine 2x. Okay, so x cosine 2x. So first, let's choose u. Remember, the u is the one we want to be able to take the integration, and also we want my goal is the VDU to simple. So in here, I can choose my x to be my u. Right, so this is x, because now when I take the derivative of what is going to happen, it's going to be 1, right? So it will simplify this integration. Okay, so now, okay, so if I take the x here, x is here, right? So then all the remaining, everything here, cosine 2x dx. What I need to say here, this is cosine 2x dx. What is this one we're going to say? This will be dv's, right? Okay, so then the same thing. You need to take the derivative, right? Okay, so what is here? So this is du, x will be 1, so it's 1, the dx, right? And then this one is here, you need to take a what? The integration. Okay, so the integrations here, so cosine integration, so it will use the u sub, you will be sine 2x over 2 here. This is equal to what? This is v, right? So we need to be very familiar with those very, very basic functions, integrations, all right? So you don't spend the time try to figure out what is that, right? So here, then uv, okay, minus v dus, right? So you color code that. So I know then this integration going to be uv, so it will be 2, this is x sine 2x, right? Then minus v du, so it's a minus 2 sine 2x dx. So far, so good. All right, so now you have here, so x sine 2x over 2, you can take this 1/2 out, then the sine 2x dx. So from the basic, so this is x sine 2x, so this is 1 minus 1/2. So what is the sine integration? Ha is negative cosines, right? So it's a negative cosine 2x, but by here, this is 2, so I need to divide by 2 here. Okay, and then plus c. So this is by the u sub, that's where these constants come from. So this will be 2 the x sine 2x minus minus plus minus plus 4 cosine 2x plus c. You see here, all right? So the key here is, of course, which one you choose to be u, which one you choose to be dv. And then also you need to familiar with very, very basic those integration formulas here. All right, let's take a look at this one here, this one. And so this is x squared e to the 5x here. So for this problems here, also it says x squared. So probably I will let this will be u, because when I take the derivative, it drop, you know, kind of the terms going down, right? From x squared to x, those things, right? So it's so I will set this is my u is equal to the x squared. After you sign the u, then what happens here? All the remaining will be what? Will be dv's, right? So you have e the 5x dx equal to dv. So everything inside the integration sign we need to cover. Okay, so now this one here, you want to take the derivative. Okay, so what is the derivative here? It will be du is equal to the 2x dx, right? All right, so now this one you want to take what? The integrations, right? Okay, so what is the integration? Is e, the integration will be itself is 5x, and then by chain rule, you need to divide by 5. Then this is v here. Okay, so now we can do uv, right? uv minus v du here, right? So let's write it out to see what happens here. So this one will be uv, so it will be x squared e the 5x over 5. Good. Then minus v dus, right? Minus v dus here. Okay, so minus v du, so it's a minus 5 over 2. 5 over 2 x to the e the 5x dx. The integrations here, right? So now you say here, whoa, you know, I still have this ones here. So let's try to simplify this a little bit. So this is a 5x squared e to the 5x minus 2 over 5. And this is x e to the 5x dx. As you can see in here, we need to use the by parts one more time. So I will set this one again. So I will set the U is equal to what? U is equal to X again, right? All right, so I do the y by parts one more time. Then here, this is the e to the 5x. So this part I need to set it to the dv's, right? So this is a 5x dx equal to dv. And now this one, take the derivative. So du is equal to the 1 dx. See, the power started dropping from x squared, drop to 1, constant. Now, the dv, this side, I need to take the integrations. So we know the integration will be itself. So it's e to 5x, but by the chain rule, I need to divide by 5, right? So this is equal to v. So this here, so that's why I need to do the integration by parts. So it becomes uv minus what? Minus VDUs here, right? So in here, we need to be very, very careful about our algebra and all these positive and negative signs here, right? So it's 5x minus 25. Okay, so this one is UV, so it's x to the e to the 5x over 5, correct? Then minus VDU. So it's a minus VDU is a 5 e the 5x dx. All right? Okay, almost there. So that's why this one is a little tedious, right? So this is a 2, the x squared e to the 5x. Now in here, this will be 2x e to the 5x, 25, plus plus, so it's a plus plus, 2 over 25. Then this is the e to the 5x dx. So let's do one more time the integration. So this is a 2, this is x squared e to the 5x minus 2x e. Okay, so this is a 5. I don't know why it continue right 2. So this is a 5. All right, so this should be 5. All right, so this is a 5. I don't know why. Okay, so this is a 5. So this is a 25 x e to the 5x. Then here, this is a plus 2 over 25. So what is the last integration here? This will be itself. But based on the chain rule, I need to divide by 5 plus c. Okay, so now I finally have my final answer. So this is 5 x squared e to the 5x minus 2 to 25 x e to the 5x plus 2 to the 125 e to the what? 5x plus c. So this problem becomes tedious because here got x squared. So that's why it turns out to be what? You know, we kind of need to use the integrated by part twice. Right? So this one we need to integrate by parts twice, right? We need to do twice the integrated by parts. So imagine if you have x cubed, and then this will continue. You know, you need to do the another integrated by part. Okay, so now let's take a look. This one's here. This is the arctan 2t and the dt. Well, so for this one, you know, looks like I really have no choice. I need to have the arctan 2t. This is my u, right? Because I know what is the derivative of arctan, but you know, in here, now in here, that's why the remaining here, this one will be what? dv's here, right? So let's write it one more time. So the u is equal to the arctan 2x, and what is the dt is equal to the d what? dv. Good job. And now I need to take the derivative, right? The pink one, the purple ones always take the derivative. So u will be du. So what is the arctangent derivative? it will be 1 plus 2t. So 1 plus 2t square. Don't forget the chain rule, 2t, you take derivative, is 2. All right, okay. And then this one's here, dt, this part I need to take the integration. Okay, so for the integration, so what I have t is equal to v, right? Okay, so now do the same thing, do a cross, so will be uv and minus vdus here, right? So, okay, let's try to write it out. So the UVs will be, what is the T times the arctan 2T, right? Okay, so then minus, right? Minus the VDU, so it's a minus VDU, so it's a minus 2T. So this is 1 plus 4T squared dt. All right, so here I should have always put the dt here. Okay, so now I need to integrate this part here, correct? I need to integrate this part. And this part, wow, this part seems is 1 plus 4t squared, and here is 2t. So what do we need to do? We need to use what we call is the U sub, right? That's what we learn at the very, very end of the calculus 1. So the U sub. Okay, let's take a look at what is the U sub going to do. So I said U is equal to the 2t. Oh, I'm sorry. So I will say the U is equal to the 1 plus 4t squared. Okay, U sub, we say du is equal to AT dt. Do you remember that? Okay, so now here in the U sub, we always say here, because you need to match the 2t dt's, right? So here is a 2t dt, but here is AT dt. So what I need to do is here, I need to only have so here I will only have a 2t dt. So if you divide it by 4, so what here, the du need to divide it by 4, right? Okay, so now this one's here. Finally, I can replace this one. Okay, so let's continue here. So the first term, nothing changed, is the arctan 2t, t and arctan 2t, and then minus. All right, so take a look at 2t dt is what is du over 4, right? So put 1/4 here. Then 1 plus 4t squared is u, so this is u. Oh, wow, that's pretty good. So this is a t arctan 2t minus 1/4. What is 1 over u? We learned it's a natural log u plus c, right? So now finally we get our answer. This is arctan 2t. Then minus 1/4, substitute what is your use here. So it's 1 plus 4t squared plus t, right? So you substitute back your use here. Of course, here we have so many use here, so don't get confused here, right? All right. Okay, so let's take a look at our last problems here. It's a sine x, cosine x. In fact, this problem here is kind of like the introduction problem to our next lecture series. How do we do the integration involve the trig functions? When you learn in the next lecture, then this integration will become pretty easy. But now let's take a look at how can I use the integrate by parts. Okay, so either way you work, right? So like after the next section, then you will say, oh yeah, that will be pretty easy. Okay, so now in here, let's say I want you to integrate by parts. So here I will say u is what? Sine x. All right, and then the next things here, all the remaining, remember, all the remaining has to be dv. So I know the cosine x dx has to be dv. So just like the previous 4 problem, we need to take the derivative of this one. So this is a derivative. So this is a du. What is the derivative of sine? It's a cosine, right? So it's a cosine x dx. How? Now, what is this side? We need to integration, right? So what is a cosine x integration? Is a sine x. And what is here? It's v here, right? So you integrate. So now I can say uv, right? Minus what? Minus v du here. Okay, so let's write that out, right? So it's equal to uv, u and v. So it's what? Sine square x, right? Minus v du here, minus v du, minus sine x cosine x dx. Then you say, oh boy, it seems like after I did it by parts, oh, here, what happens here? Oh, it become my problem again, the sine x cosine dx. So even I do another by part, I always have this term. Oh, what can I do here? It seems I can never get rid of the sine x cosine things. So now you say, because I'm looking for the sine x cosine. And so let's try to do this. Let's add move this whole part to the left-hand side. So that means let me add the sine x cosine x dx, both sides. Okay, so if you add both sides, what happened to here? So you will have like 2, the sine x cosine x dx, right? So when you add in here, so if you add this ones here, what happened will cancel. So the right-hand side will become what? Sine square x, right? So of course, here you have a constant c here, right? So now you see, oh, okay, so this is 2 times, so I can divide by 2. So now I still can get my integration. So this is sine x cosine x dx is equal to sine square x over 2 plus 2c over 2. You can say some are just other constants. So that is my integrations here. All right. So this is a very, very important techniques here. All right. Okay. Because when you try, when you try to do the integrated by parts, arbitron in here, they come out as what you have original. So seems like your integrated by part cannot simplify it, but then you recognize they are exactly the same. So you can just add that, so you will become 2 times the sine x cosine x equal to sine square x. Now you still can solve it by divided by 2, right? So this is a very, very important kind of the techniques and the problem, but also like when we talk about in our lecture number 2, when we talk about the integration techniques by using the trig function, then this one will become super easy to solve also. All right, that's it. That is what we call this integrated by parts. As we can see, some of the problem become pretty tedious here, right? So our next video, we're going to redo some of the problems here by using the table methods here. So when we're using the table method, I think it's a lot easier, and the chance to make an algebra mistake is pretty small. It's smaller than, you just do all this, the integrated by part once, integrated by part twice, those things. All right, that's it. And nice talk to you. And we will take a look at the integrator by parts by using the table methods here for our next video. Okay, so nice talk to you. Have a good day. Okay, and bye.